At the end of the last session, the question came up. So some of these treatments are pretty expensive. How can we decide which treatments to prioritize? How can we decide if we can have the treatments that are less expensive? Some of these things are market forces, some of these are technology, but some of them are bigger political discussions. The speaker who's up next is going to be talking more generally about how can we improve our decision-making systems. Can we move from our present way of making decisions, which have got pros and cons? Can we incorporate technology? Can we incorporate artificial intelligence? Can we incorporate any other mechanisms so that we have more of the wisdom of crowds rather than the chaos of crowds? The speaker is Dr. Anders Sandberg, who is a James Martin Research Fellow at Oxford University. He has a background in computational neuroscience. He is a philosopher. He is widely read. You may have heard him quite often recently on television and on the radio talking about various aspects of the future. We're very lucky to have him today, so welcome Anders Sandberg.
Thank you very much for having me here. So I might have started out in computational neuroscience, but then I lapsed over into philosophy, which, as I usually quip, is a great place to do anything you want, because you can typically claim this is philosophy. So that allows me to study a bit of economics and a bit of neural networks and a bit of this and that. But contrary to some of the other talks, I might actually start out a little bit with the classics. Not just because we're kind of cobwebbed historians over in Oxford that think that anything happening after the 15th century is too newfangled to be really trusted. But also because the classics actually do contain a few interesting issues. And of course, we have this archetypal situation of having to make a decision. So this copper plate engraving shows Heracles at the crossroads, a kind of famous motif. Heracles needs to choose what life to lead. And there are two ladies, one symbolizing kind of taking the easy path, going for pleasures, for a worldly success, and the other one going for virtue, doing something really heroic. And in this copper plate engraving, they're kind of arguing their case. And underneath it says, deliberatio omnium difficilium. Well, my Latin is really crappy, sorry. But this is the hardest question of all. How do we lead our lives? That's really the ultimate form of decision making. I'm hoping to get back to that. But most of the time when we talk about decision making, it's a cognitive process that results in us selecting a belief or an action among several different alternatives that we think is best. There are different parts here. One is, of course, to recognize what the alternatives are. Heracles just has two different roads to travel. A stockbroker has hundreds of stocks to buy and sell, and a programmer can write any code whatsoever. But there's also the question about values. What is good? What is a good piece of software? What's a good selection of stocks? In some domains, this is very easy to tell. In others, it's actually very unclear. We also have this problem of comparing things. It's one thing to try to maximize the amount of profit you're making in business, another thing to try to make the best possible book. They can be very different, and how you compare the different kinds of books is non-trivial. I could write a popular book or a really dry academic book. One would give me fame and I would end up on TV. The other one might be read by very smart people very far in the future, hopefully. And so on and so on. It's interesting because, in general, we tend to think that this ought to be easy. We have a few alternatives. Let's select the best of them. Sometimes it might take a bit of work, but it's not in itself that complex. However, now we're, of course, suffering from the modern crisis here. It's really interesting to compare the ancient Greek world with our current world. Even if you look at the debates they were doing at the Agora of Athens, and we might again recognize a lot of the politics and personalities and style going on, many of the questions at the surface were fairly similar. Should they go to war against Sparta or not? What about taxation? But then, of course, the tax code of ancient Athens was probably rather short, while the tax code today is, of course, very, very thick. Nobody really truly understands it. Indeed, it's not just that we have many, many more options, so many options that might be hard to handle. It also is that many of them are about very complex systems. Some of them involving systemic risks. If we do one thing to the market or one thing to the climate, very complicated things might happen down the road, making it very hard to tell what we ought to be doing. We also have a problem that we started to recognize that there are actually quite a lot of different ways of making a decision. One of the paradoxes of decision making is that you need to choose the method of decision making. How do you do that? Well, you can use some meta decision making method, and now of course you can imagine an infinite regress, or just giving up and taking the one that looks easiest. But that is not a very principled approach. We also have this problem that the uncertainties is not just about the choices being uncertain, but even what choices are available. So when people talk about black swans, quite often the best meaning of that concept is the option or possibility of threat that nobody thought about, that nobody recognized was within the realm of possibility, so nobody protected us against it, and that's why bad things happen when the black swans show up. We also have to deal with many more voices that are also very different, that have different views on what is good. Again, the Greek agora was a pretty simple place where just the three men could congregate. It wasn't that many people. There were probably fewer than the people in this room. But today, it's not just that there are women involved and people from other cities, but also other cultures and other generations. Our generations are becoming more and more different because as our lives get longer, we get exposed to very different media experiences. And this can sometimes lead to polarization. I don't want to get too deep into the question whether we actually have been seeing an increased polarization, but it's certainly true in some domains, people do seem to be drifting apart. Sometimes we can blame that on media and saying, oh yes, there is a kind of echo chamber where we all choose our inputs that fit with our views, and then we get more and more convinced about our righteousness, while those guys are totally mad and wrong and evil. So I don't need to listen to them. Which is one of the dynamics that might be going on. But I think another problem might be even a lack of shared language when you're a very diverse group. You might not even agree on what is a proper debate. What are the forms of a proper discussion when somebody actually comes from an utterly dissimilar online culture than you? We also have this interesting problem of irrationality. We have always had fools, of course. The realization now is that actually it's not just in general that we're a bit foolish, but actually we're pretty much more irrational than we have traditionally thought throughout the Enlightenment. It turns out that we have a lot of cognitive biases, and we're even bad at predicting what makes us happy, which is a downright frightening thought when you start to realize the full implications. It turns out that in psychological experience, people don't know really what choices will make them happy. And even when they know it, they still don't make the right choices. So this is kind of breaking down this image of a rational decision maker. And that is a bit problematic, both in economics, because we have always assumed economics was built on the rational homo economicus that always maximizes his gains, but also in politics and law. Again, we have this idea that we're rational people doing somewhat sensible things. If we're not that rational, how should we trust the political process? And finally, we have a problem that the size of these problems we're facing might get much larger. We're facing a world that might be facing much bigger risks. So this is an example of an actual PowerPoint slide. It's rather infamous by now from Afghanistan. I think it was Rumsfeld who said, and by the point we have understood it, we have won. The problem is, of course, this is probably a relatively accurate, simplified model of what's going on at the time in the society of Afghanistan. It has changed since then, of course, and it was an oversimplification. We need to make decisions about these things. And setting priorities is also hard. So this is from some of my friends who are working on charity, looking at the cost effectiveness of various interventions. And you can get many orders of magnitude difference, which means that if your priorities are in the slightly wrong order, you might actually be missing out most of the value your charity could be doing. So spending a lot of effort getting priorities in order might actually have an enormous effect. But when the most effective thing here is about 2,000 times more effective than the least effective, in that case, we really should spend a lot of effort on it. And of course, if we look at bad collective behaviors like wars, we also realize that statistically, if we extrapolate, the probability of getting wars of a size that threatens the survival of species is not that low. The probability per year, if you just naively extrapolate the Richardson law of war size, is on the order of, one humanity-destroying war every 1,000 years. If somebody will telling you, well, this is a great investment, you're making a lot of money, except one chance in 1,000 where you lose everything and actually the whole industry goes bust. Many people would say, is that a good deal? Would I get on an airplane with one chance in 1,000 of crashing if I knew that? Probably not. But we're still accepting that in our global system, which is downright horrifying. So we need to do something about this. So in general, giving up is not an option. One can start looking at the individual level. And I think in general, it's pretty obvious that we can do a fair bit to reduce our biases and irrationality. The traditional humanistic project have always been about, if you just give people good culture, good information, rationality and training, people will become better. And I think this is true to a great deal. Quite a lot of bad behavior are happening because of ignorance, and you can actually fix that. Cognitive biases are a bit more tricky because they come about because of the way our brains work. It's possible to unlearn them, and in other cases we might at least recognize them. For example, one of the most frightening biases I know of is anchoring. If I mention a number, let's say my phone number, and then ask you about the population of a city, I can statistically show that your estimates will gravitate towards my telephone number. Yeah. Now, why would my phone number have anything to do with, let's say, the population of Montevideo? Nothing at all. But our brains are not very good at keeping these two totally different pieces of information separate. And this, of course, leads to mistakes, especially if the previous number might have been a previous estimate somebody says at a meeting, and then you actually have an accurate number, but people would tend to gravitate towards the first one. And this doesn't disappear just because you know about it. You need to kind of find ways of washing your mind by looking at a lot of numbers maybe, or carefully setting up your meeting so you don't get stuck too easily on things you shouldn't be stuck on. It's possible to train calibration, the ability to make probability judgment that actually come true well enough. The two groups that are generally best calibrated on probability tend to be weather forecasters and bookmakers. Especially the bookmakers are very motivated to get the odds right, because otherwise they lose money and soon will be ex-bookmakers. And this is something you can train. You just make a lot of predictions, and then you check, okay, I think I'm 90% certain, I think it's 90% chance that this will happen, and I'm 80% certain it is true. And then you check how many of your predictions actually come true, and how well your confidence intervals actually fit reality. It's hard work, but it's very useful to do. And you need the feedback. I'm going to get back to that. The other tricks, I don't have the time to get into it. There are sometimes you can fix them institutionally. Like, for example, in a police investigation, but it's mandatory after a while to do a session where you discuss why couldn't the prime suspect have done the crime. It's very easy to find all the evidence pointing towards the prime suspect having committed the crime. And after a while, of course, you're not going to even notice all the things that actually speak against that. So putting that into the institutional framework is very effective. It's also necessary because policemen will not do this spontaneously. Nobody in the right mind starts thinking that maybe I'm wrong, because that would be too unsettling. You need to actually make a habit out of it. In intelligence agencies, they have various structured assessment techniques trying to do this. Again, to channel our normal propensity for trying to evade that by putting it in the rules and making boring checklists out of it. Also, of course, we can aim at getting more evidence. So there is more data available than ever, which is not necessarily a good thing for making good decisions. Generally, combining that statistically, I think we should be teaching kids more statistics so we can make some sense of it. I think we need to come up with better tools. We haven't done it yet, but we really need to do it. Also, of course, randomized controlled trials. They work really well in science. The UK is unique in actually having started thinking about maybe we could do this also in government. Of course, nobody in their right mind will do a randomized controlled trial about something they really care about. So don't expect them to see them affecting the NHS or schooling, but small things like sending SMSs before sending out the bailiff or something like that. That's small enough that people actually do trials and actually figure out ways of improving things. We might want to think about it in companies. Why not do more randomized controlled trials in a company? Okay, so we have various ways of fixing the biases. In general, we can of course also try to listening to experts. And it turns out that we're experts on expertise, which I think is a really awesome thing. So here's one of my favorites, James Shantou, and he pointed out that experts are typically not experts on everything in their domain. They might be an expert on cattle meat quality or a nuclear power plant. That doesn't mean that they're really good at everything that has to do with beef or in power plants. But certain tasks, whether that is predicting the price of beef or predicting how much radioactivity you get out of a particular piece of a reactor, they tend to be rather good at. Because the task, the particular property there, is something they can learn of. So he found various aspects of tasks that people can learn and become better at. And the main thing is, of course, feedback. The beef inspector will see a lot of beef and will also taste it and see whether his or her judgment were right. The power plant guy will be seeing a lot of power plants, and occasionally accidents or problems will happen, and they're going to notice what works well or not. The problem happens when you don't get feedback. In insurance, which is an area I've been working with, the problem is many catastrophes are so rare that you can actually go many years into your career without ever having experienced your company having major losses because of a hurricane. So your view of what's normal is based actually on a situation that is unlikely to persist. And of course, when talking about the future, and this is why the futurologists have such a bad reputation, we don't get much feedback from the future normally. Any time travels are allowed to disagree, but normally the future is pretty quiet. And that means that it's actually very hard to become a good expert on the future. So when the nuclear power expert very confidently makes a prediction, he's actually speaking about something where we shouldn't expect him to be that great. And indeed, it turns out that many domain experts are absolutely lousy at predicting the future of their own domain, because that is a different kind of expertise. So this is already interesting because it can tell us a little bit where we might expect our decision making to be good or bad. But we can learn more. We can, of course, look at forecasters. So one of my favorite forecasting experts is J. Scott Armstrong. And I like to call him the leader of the grumpy old man school of forecasting. That is, if you look at what people are doing, you can show that they're doing it wrong, and they're doing it again and again, and they don't learn anything. This is all in his very nice book, Long Range Forecasting, from, I think, 1972. He's still saying it today, and it's still true. Just because that book has been out doesn't mean things have changed. One interesting graph he has is exactly how good of a forecast when you take more and more expert people. And generally, if you just take random people, they don't know anything about the domain, and then they're actually rather bad. Then it goes up rather quickly. And for the really expensive experts, well, they are not necessarily good. Quite often because they have better things to do than actually telling you about the future. They are very well paid, and they're certainly going to have a nice large fee, but they're not necessarily very good at the topic. So actually, if you can get cheap experts, and a lot of them, it will work better. He also points out that actually using different methods for forecasting tend to produce more reliable and robust results. And I'm going to return again and again and again to this point because it's very important. Also, people tend to overdo it. People love complicated methods. And why just use a trend when you can add a Delphi to it and then run it past some principal component model into a big computer model? And why not add IBM Watson's AI to it too? With that many cool components, the result must be absolutely true at the end. Of course, you can realize that if you get any of that wrong, you are just going to get garbage out. But if you express it in the right way, people fall for it again and again and again, which is deeply depressing, but also suggests that if we actually care about the future because we want to live in a good future, we might want to use some other methods. Another interesting criticism of forecasting is from Philip Tetlock, who did a really painstaking study of political experts. They're making predictions about what's going to happen in different countries, the typical pundits you see on television and in newspapers. And he followed up their predictions over a span of almost 20 years in the end. And the general conclusion was the height of that forecast accuracy curve was not very high. That's also something Armstrong points out. Most of them are really, really bad. Some are slightly better than others. So he used the fox and the hedgehog as his symbols of this, based on a quote from Isaiah Berlin. So the hedgehogs have one theory, whether that's dialectical materialism or free market capitalism or a gradual complexity increase or something else. And then they apply it again and again. They got a wonderful hammer and everything is a nail. And occasionally we do manage to hit the nail on the head. And we get a really good prediction, really surprising, and they're all over TV. The problem is, of course, most of the time we just miss. And nobody remembers that. Meanwhile, the foxes are putting together evidence from different areas. And if you ask them about why do you think that Russia is going to do that, their explanation is going to be a mix of simulations, geopolitics, analysis of Vladimir Putin's personality, and so on and so on. It's not going to be a neat theory. But it turns out that on average, we do pretty well. Another interesting thing in his survey is, of course, that the formal models, if you actually develop a more strict way rather than making stuff up, generally tend to do better than both foxes and hedgehogs. And if you can actually work with statistics, sometimes that works even better, much better than humans. There are these famous findings that there are certain medical decisions that actually can be boiled down to simple yes-no choices. You can generate them using statistical method, and they outperform experienced cardiologists. Cardiologists don't like to hear that. They're relatively specific things, but you can kind of figure out things that outperform experts here, because you can distill simple rules that tend to get lost in all the details, because we tend to confuse ourselves as humans. Now, one other way of dealing with this is, of course, to have a group. So this guy is probably one of my favorite futurists ever. So he actually did some wonderful work about where the trends of his time were leading, and suggested that, yes, people are getting richer and we're getting more equal. Maybe women will get the vote eventually, and it looks like technology is poised to do dramatic things and so on. He was writing this during the French Revolution. And since he was a count, he actually did lose his head in the French Revolution. But he's also famous for his theorem, saying that if you have a group of people and they have a certain probability of being right about the question, and then they just vote about yes or no, the probability of them getting it right becomes surprisingly close to 1, as long as they're not as they're making independent decisions. So they need to independently vote, and in that case, actually the group, who might be rather dodgy otherwise, will get it right. And this has been used as a strong defense for democracy, of course, although the problem here is, of course, the independence part, because we all read the same newspapers, we might be discussing with each other, we become correlated. But generally, the jury theorem shows a very nice trick we can use. Take various predictors or various pieces of advice, which are individually rather weak and might be wrong, and weigh them together. And we can actually get surprising amount of correctness out of that. We can kind of squeeze out correctness. This is why some game shows have one kind of lifeline where you can ask the audience. And quite often the mean audience response to a question is quite correct. So this is, of course, what's behind the hype of crowd wisdom to some extent. I'm going to return a bit to that later. But it's interesting to see that this also has an echo right now in what's going on right now in statistical machine learning. Because we have another problem when we're trying to teach our machines to do the right thing. We can give them a lot of examples, and then we want them to classify something to belong to different categories, like right or wrong, or high value, low value, and give a credit score if somebody wants to apply for a credit or something. So we have a lot of examples. And then we need to find decision boundaries, so where these different inputs would lead to a different decision. And the problem turns out to be that this is rather hard. But it was discovered by Shapiro in the 90s that, yeah, you can actually take a whole bunch of relatively weak learners and put them together to a joint system that does much better. This is essentially the jury theorem, but applied to software. And you can do a lot of fun stuff this way. And people have been having great fun developing this very elaborate system, taking various machine learning methods, including taking totally different ones and combining them to get joint decisions. The nice thing here is that you can not just fit together things that on average get it right, but you can have specialization. A method that works really well for this kind of cases, but badly at those, is combined with something that does well on these cases and badly at those. And now you get something that works well on both. You can use it when you have two large data sets to train the full classifier. You can use it when it's small data sets by using various statistical trickery. You can use it for various forms of data fusion when there's very different kinds of data. So different classifiers handle different forms of input. Generally, what's happening here is that we're kind of taking Occam's razor, keep things simple, and throwing it away in exchange for getting a very nice big club of statistical machine learning that's very robust. It's not as elegant as the razor, but it actually gets a lot of job done. One beautiful example of this is the Netflix prize a few years ago, where people were competing in predicting what films people would like, given what other films they had liked. So a lot of teams were trying things out, and they had a ranking list, and they had to announce the methods they're using. And what happened towards the end was the teams started merging together and getting much better performance. The interesting thing is that the winning team at AT&T, that's the red one, they had been combining various other teams, and the second place team had gotten even more teams involved. In many cases, teams that had a slightly good idea but a bad implementation could really improve the other team that had much better idea and better implementation by adding their unique idea. And you got this larger and larger, very complicated method that managed to handle a lot of the special cases. And this is also a beautiful example of how a kind of organic organization really can help. In a normal competition, teams are not allowed to merge. But here they did, and that worked out really well. It's also interesting to note this is a recommender system. It's presumably trying to help you make a good decision about what movie to watch. Although, of course, it's going to be tilted, presumably, towards what Netflix might have an interest in you watching. Generally, group problem solving works really well because of this reason. We smooth out the individual biases and problems. It really works well when the solution is very verifiable, when everybody in the group can tell that, okay, we've solved the problem, we found the best alternative. It's really bad when we can't even agree on what the alternatives are. So figuring out what to do in the Middle East, that's not a good example of what group problem solving does. It also normally has scaling issues because people need to talk to each other. And again, there are various interesting innovations here because technology allows us to coordinate more and more, which is why we see this graph of the number of authors in scientific papers just going up exponentially. You can bring in people from very different disciplines now, and you can network over larger domains. The problem is, of course, we also have a stupidity of crowds. One guy in the jury who is absolutely convinced he's right might be biasing all the others. We have the stock market bubbles, and there is even this interesting data showing that the number of members of cabinet in different nations negatively correlates with the quality of life in the nation. The more politicians you have in the cabinet, generally the worse the policies are. So obviously we need to fix this. It turns out that Tetlock got some interesting results here because he didn't keep on just thinking about individual forecasters. He then started in a big project run by IARPA, the Intelligence Advanced Research Project Agency, a big US organization kind of trying to do blue sky research for the intelligence community. And they're, of course, very interested in doing good forecasting. So they tried a competition for different forecasting methods, different ways of getting experts or lay people to predict what's going to happen. What's the oil price going to be? Who's going to succeed the president of that country? And Tetlock's team, they found some rather interesting things. First, different people are differently good at making the forecast. So the graph to the left there, the red line corresponds to a rather bad forecaster. You want to get a low error score. That is what's going on in this diagram. While the blue-green one corresponds to one who's consistently pretty good. And this is based on a prediction on the first month of the forecasting. And people are fairly consistent. Some people are much better at forecasting than others. Then you can start looking, what if we give them training? What if we tell them about the base rate fallacy? What if we train them about cognitive biases? Does that improve things? Turns out that it does. What if we put together people into teams? Can teams outperform individuals? Oh yeah, they can. And then you can, of course, permute things together. The really interesting thing that Tetlock did was to take the best forecasters. They evaluated how good the forecasts were about what's going to happen in the next few months. And after a while, they put them into teams of what he called super forecasters. And they're really amazingly good. So now the Good Judgment project has become Good Judgment Incorporated and is commercializing this. And it seems to be a pretty good idea, actually. Yeah, find experts. The problem is, of course, that most self-proclaimed experts are not real experts. You actually need to test them to see whether they're good. So the policy experts, they are experts in getting published and getting into TV rather than getting things right. So you want to have measures of what is working. So I'm going to rush onwards here because I can obviously go on absolutely forever. So one important component here was doing statistics to this. That's an imperfect tool, but it's quite powerful. And if we have data, in some domains, we can actually make a proper simulation. We can simulate climate. We can even simulate various theories about climate. We can simulate our economy. And we can combine them. Instead of just trying to find the best possible simulation and believing that 100%, we realize that we have a range and we try to make our policies fit to that. Given the growth of big data, we might also be getting to a situation where in some domains we can get all the data. We can actually simulate flu epidemics by modeling all members of the public because the NHS got their health records. Some privacy and integrity concerns over there, but from a technical standpoint, this is looking more and more doable and might actually be a pretty useful way of getting good models. So we can, of course, also combine that with artificial intelligence, which we're going to hear much more about in the next session. But the interesting part here is artificial intelligence would be nothing without getting all the input. The big input is actually what's making things possible. And it's important because it is a non-human second opinion. It's not necessarily what ought to be making our decisions, but hearing something that doesn't think like you express what it estimates is best is sometimes a very useful thing, especially if you can also then trace it back and see what's going on. There are some interesting problems here about how this can lead to centralization, etc., but let's hurry on. And of course, we have all forms of crowdsourcing systems, which are interesting because these are all about creating group agreements in various flexible ways. And again, the trick is to set up software that channels our individual group interactions in effective ways. And my favorite example is from Oxford, the Galaxy Zoo, where we simply have the people online categorizing galaxies. This is a boring task that grad students in the astronomy department refuse to do more than a few hours. But there are a lot of people online who love doing it. It's very relaxing. Spiral galaxy, elliptical galaxy, spiral, irregular, what? I don't know what that is. And then you gather the data. And for a given galaxy, you can then, of course, have 10 different people see the same galaxy and you go with the majority. The interesting thing is they discovered that you can actually do a lot more statistics. There is an awesome paper where we do advanced Bayesian statistics to figure out who's conservative, who is more willing to guess that that must be a supernova versus those who really will only say supernova if it actually is a supernova in that picture. So you can combine them, just like we might be combining the ensemble learning systems in machine learning. and the models to combine different users to make a tool that gets better. And over time, as you use the Galaxy Zoo, it learns how good and accurate you are. Sometimes it gives you Galaxy that you know perfectly well what they should be, and if you answer differently, then you're weighted slightly less. This way, you get more and more accurate estimates. And then you can start branching out in other areas of science, which the Galaxy Zoo people have been doing. So, Wikipedia also demonstrates this, and the whole trick is really that you do a bit of stick merging. The system shapes itself after how we use it. So that leads to the final, really tricky question. Individual decision-making can be hard enough, but joint decision-making is not just the best answer, but also an acceptable answer. We all need to agree more or less that this is an okay answer to the question. So in many ways, this is information limited. Again, this is a long tangent, which I really would love to get into, but I don't have the time. But basically, we have seen nothing yet. There are very good reasons to believe we actually haven't seen even the first 1% of the possibilities enabled by the internet, by statistics, by modern information technology. Essentially, the kinds of governance and policy making we can do are limited by the technology for information processing we have. And when those limits go up, it takes a long while for us to invent our stuff we can do there. So I'm just briefly going to go through stuff in the policy cycle we might do here. So setting agendas, for example, big data is good at giving us answers, but doesn't tell us what questions to ask. And asking the right questions is really important. Sometimes simulations can tell us when something is wrong. Having large, diverse groups that chat online and can get cascades of messages to each other is a very good way of getting early warning signals and notices of something being tricky. However, we also compete very much in the agenda setting part. The policy formulation step is interesting. This is where we can actually have groups competing and suggesting good inputs. Here we can actually use our simulation statistics to actually test policy options to some extent. And also having more groups that could actually suggest options. So the Icelandic parliament tried Wikidemocracy to some degree. They actually had a kind of online constitutional process where people were suggesting changes and modifications to a draft constitution. That was an early experiment. I think we can do much better. And of course, people are inventing interesting tools for distributed decision making, like liquid democracy, where again you use a software framework to try to frame the debate. And also, if I know I don't know what I'm doing, I might delegate that to David, who generally has good and sound opinions on most things. So he might vote with my vote. And we can set up pyramids of this. So some representatives might represent blocks in a very fluid way, because I might suddenly decide, no, I don't trust David, I'm going to trust you. So in that case, I move my vote over and the blocks are shifting. How to get this to work socially is another interesting question I don't have the time to get into. But there are problems that right now these are tools developed by nerds, which means that it's mostly about nerd politics, which generally doesn't quite link with the bigger politics we might care about in all of society. We need to fix that. Generally, it seems like the big gridlock in international decision-making right now might be that we have been trying so much getting total consensus about everything. That doesn't work. So one idea the Oxford Martin School have been championing is that actually set up coalitions of the working. Yeah, not everybody agrees on climate change, but those countries that they do agree on climate change, they can actually get together. Those countries that think we need a joint cyber and risk management, they can go together, and then others can join when we see this working. This is also where I think the debiasing tools I mentioned can get really powerful if we actually force them into parliament, which is going to be very tough. People make political decisions when they're sleep deprived, which is equivalent to having drunk a bottle of wine. Whenever people come out of these meetings and say, we saved the euro, think he's swigging a bottle of wine. We saved the euro. We would never accept a political leader who was drinking and making important decisions. But we do accept people having all-night negotiations as if that was a symbol of them actually being devoted rather than actually making rather confused decisions. We can also improve the implementation in the interesting ways. There are various ways of making outsourcing better. There are some really radical ideas like Robin Hanson's Futurity. And you can even automate policy implementation. So right now, of course, no talk about the future is complete without at least one mention of blockchain. So here it is. And blockchains are not the interesting part. It's smart contract. We can actually imagine policies being set up as a smart contract. The government announces that it will do this if these conditions happen, and then that much money will be paid out to whoever does it. And then just put it into the blockchain. So it guaranteed will happen, no matter who is in political power or whether the government changes their mind. There are interesting other possibilities and risks here with automated policy implementation. It's sometimes rather good to have some people involved saying, hey, wait a minute, this policy is stupid and I'm willing to stake my entire career on this being wrong. Stanislav Petrov, for example, in 1983, he went against Soviet policy and didn't press the button because of when a computer error told him that the Americans had launched the nukes. And we should be very thankful that that guy totally went against policy. And this is why automated policy might be slightly risky. Maybe we shouldn't have that for our weapons. We also, of course, want better evaluation. And again, getting that to feed back in an authentic way, and maybe automatic auditing and things like that. Finally, we also need to have better debugging methods. And again, we can borrow a fair bit from software, actually. I think the most important thing is it takes a lot of testing to make software bug-free. It's quite useful to do simulation and have a red team trying to hack it. It might be good to actually have political hackers trying to hack our political systems. At least before we implement the policy, they should try, how much money could I get from faking something with the new proposed law? And finally, the final word. This is not necessarily a talk about how to get to a wiser world. This would be a world where we make better decisions. And a good decision is not the same thing as a wise decision. Wise decision is about selecting what problems we want to solve. It's not just selecting the best of the alternatives, but deciding, hey, those alternatives are all wrong. I'm going to go over here. And with that, thank you.
We are a bit behind schedule. I think we may have time for one quick question on Anders' session, and then we come back to more Q&A at the end. So where should we go? Gareth?
Just one quick question. Shouldn't we be focusing on what question to ask?
Yes and no. Spending all your time on asking what question to ask means that nothing gets done. Spending all your time on just doing stuff without knowing whether you're going in the right direction means that you have a very high chance of going in the wrong direction, actually making things worse. You need a balance. And in some domains, we can even estimate this. So in the case of a charity where the effectiveness of different interventions had this very skewed distribution, where a few were way more powerful than others, we can actually prove mathematically that it's rational to spend a fraction of the time and effort and money that is actually fairly comparable to many of the interventions themselves on just getting them right. That is the smart thing to do. So in many of these situations where the stakes are really high, a lot of deliberation about the right question is actually really worthwhile. On the other hand, there are plenty of other everyday questions where the alternatives are about the same size. And in that case, yeah, we should just try to find the best one in the best way. But there are ways of being smart about asking the right question. Thank you.
Thank you for that. I'm really interested in e-democracy tools and websites, as well as offline sort of methods and approaches for basically involving more people in taking responsibility for their cities, their schools and organisations. Bringing people together to make decisions. So yeah, really interesting theme to me. Question is, I'm really interested to know what projects that are emerging that you're most interested in, that you've seen sort of popping up, because I've certainly seen individual developers working on things that now have hundreds of thousands of users, and in Iceland and Democracy OS in Buenos Aires, and I want to know what you're interested in, you've seen pop up. And secondly, what is it in your mind that separates kind of pretty rubbish web platforms for kind of e-democracy and large-scale decision-making and really good ones?
Time. I think right now, all e-democracy platforms are going to turn out to be rubbish compared to the ones that we are going to have a few years down the line. Just like early democracy was really rubbish compared to the kind of democracy we got today. And hopefully we can come up with some democracy 2.0 that makes our current system look like nothing. So the problem is we need experience, we need testing. And one of the fundamental problems right now is rather small groups that are trying things out. Many forms of democratic activity that is happening today are not happening in the e-democracy platforms, nor in the traditional democratic system, but in the form of the normal social interactions on Facebook, which is a really bad platform for it, but that's where people are, so that's where people talk politics to each other. So I'm excited when I read some of the more theoretical work on the e-democracy platforms, but in practice, I think none of the current ones will work. But that's a bit like early digital currencies. They didn't work either, but we learned stuff that then turned into Bitcoin, which might very well not turn out to be the digital currency either, but we're learning by every iteration. So right now, I'm not looking at any particular platform. I'm more interested in what people are learning and whether they document both the benefits and the failings, so the next version can become so much better.
So thanks very much, Anders, and we'll continue this discussion in the final session, but thanks for the time being.
Thank you.